Hi there, Mr. Holcomb here with another episode of The Math Behind the Modules. Okay, Lesson 3, the division of polynomials. Opening exercise, that means try this yourself, pause the video, see if you can do it, and come back and see how you did. All right, so it says multiply these polynomials using the tabular method. All right, well, the tabular method is when you have something like this. There's a tabular method, 2x plus 5. And then split those up. And then down the side, we're going to write the other polynomial, x squared, 5x, and 1. All righty. I'm just setting up my table here. This is why I'm not a fan of this process. At this point, it just seems a little much. Okay, so here we go. X squared times 2x is 2x cubed. X squared times 5 is 5x squared. 5x times 2x is 10x squared. 5x times 5 is 25x. 1 times 2x is 2x. 1 times 5 is 5. Okay, and then you multiply the diagonals and get the products. So 2x cubed is all by itself, so it's going to give me 2x cubed. 10x squared plus 5x squared is 15x squared. 25x plus 2x is 27x, and then this 5 is all by itself. So this equals, and then here's your answer, 2x cubed plus 15x squared plus 27x plus 5. Okay, so there's A. B, how can you use the expression in part A to quickly multiply 25 times 151? Well, let's take a look. Okay, so if you look at this right here, 25 times 151. Well, how do I get 25 from this? Well, if x is 10, 20 plus 5 is 25. And if x is 10 here, 10 squared is 100, 5 times 10 is 50, that's 150 plus 1. So if we let x equal 10, then we put it in here. So we would say 2 times 10 cubed plus 15 times 10 squared plus 27 times 10 plus 5 equals something. Well, 10 cubed is 1,000, so that's 2,000. Plus 10 squared is 100, so that's 1,500. Okay. And 27 times 10 is 270 plus 5. Well, 2,000 plus 1,500 is 3,500. Here's 3,775. 3,775. So if I go to my calculator now, okay, and I multiply 25 times 151, I get 3,775. Okay, so if you notice what value for this variable would make this come up to here, that's what they were doing. So plugging in 10 to this polynomial and expanding it out will give you the value quickly. All right, exploratory challenge 1. Does 2x cubed plus 15x squared plus 27x to the 5th divided by 2x plus 5 equal x squared plus 5x plus 1? Justify your answer. All right, so what are they doing here? Well, they're taking our answer right here and putting it in the numerator. And they're dividing by this factor and calling it the denominator. And we're getting the other factor of this product. Okay, notice all this terminology I'm using. This is multiplication, and this is the product, an answer that you get when you multiply. This is a quotient, an answer you get when you divide. And when you take a number divided by something and get something else, the thing you divided by and the thing you got are called factors. So we're basically factoring a polynomial here. Okay, so justify my answer here. Okay, so they gave us this tablet down here. So how do I explain this? We're working backwards. So if we go back up here, we took 2x plus 5 times x squared plus 5x plus 1, and we got this product. So now we want to justify that the division of this is going to get us that. So if I take this 2x cubed plus 15x squared plus 27x plus 5 and put it outside, out here, 2x cubed, 15x squared, 27x over here, and 5 right here. We're working in the opposite direction now, okay? So we're going this way instead of the other way, okay? We're working backwards. Well, if we're multiplying and we're going this direction, division's the opposite direction because division is the inverse of multiplication. Okay, so if I need to get, so this value here, since it's all by itself, would have to be 2x cubed. And this value is all by itself, so that has to equal 5. But there's a multiple of things that this could be to give us 15x squared, positives and negatives. It could be infinitely many values. And same with this 27x. It could be 26 and 1, 25 and 2, 24 and 3. And that's not even talking about negatives. Okay. But if we look at what we're dividing by and we put this over here, let me do a different color. And we put the 2x here and the 5 here. Well, that's going to be 5 times what is 5? Well, that's going to be a 1 right here. And if I get 2x times, now I can fill this in, 2x times 1 will give me 2x. So then when I'm working backwards, 27x, I get a sum of 27 and I have 2. So this has to be 25x. And 5 times 25, or 5 times what value is 25? So this would have to be 5x. Okay, so we're just working backwards and filling in the blanks. This has to be 5x because 5 times 5x is 25x. So now that I have this, 5 times 2 is 10x squared. Okay, and then since I have a 15x squared here already and I have 10x squared here, I need a 5x squared here. And how do I get 5x squared from 5? Well, I have to multiply it by x squared. So 5 times x squared is going to give me this value here. So I worked this backwards and notice what happened. We have 2x, or we have x squared, 5x and 1, x squared, 5x and 1. So you take the product, divide by 2x plus 5, and we get x squared plus 5x plus 1. So there is the inverse of multiplication, which is division. Okay, page 2, number 2, it says to describe the process you use to determine your answer from exercise 1. Well, I explained it as I did it. So if you need to go back, drag that bar along the bottom there and go back in time. I'm going to continue to number 3. It says to use the reverse the tabular method of multiplication to find the quotient of 2x squared plus x minus 10 divided by x minus 2. So if we put the 2x squared, x, and minus 10 here, and the x minus 2 over here, just like the last time, we focus on these two corners because they're all by themselves. If this is negative 10, then this has to be negative 10. And if this is 2x squared, this has to be 2x squared. So now that I have that, I just divide to get my value up here. So negative 10 divided by negative 2, a negative divided by a negative is positive, and 10 divided by 2 is 5. So negative 2 times 5 is negative 10. So I know this is 5. X times 5 is now 5x. And I have an x here. So to get x from 5x, I have to take away 4 of them. So minus 4x here. So that way I can find this value. Or I could have done it from here. To get x to 2x squared, I need another 2x. So x times 2x is 2x squared. Negative 2 times 2x is negative 4x. So I divide, and this is my answer. So this is going to equal 2x plus 5. Okay, number 4. Test your conjecture. Create your own table and use the reverse tabular method to find the quotient of this. Whoa. All right, so I need a x squared and a 1, and I have to have a space for my linear term, so be careful. So here's what we're going to do. I'm just going to draw my two sides first, like so. And I'm going to write x squared here, 0x here, and 1 here. All right, that's my beginning. There's my right side. All right, I'm going to continue with making this table now. Come down to here and over. All right, we have 1, 2, 3, 4, 5. So I'm going to have, this is going to be 3. Let me make that a little more uniform. Oops. Okay, that's a little better. All right, so I'm taking a 1, 2, 3, 4, 5 terms, 1, 2, 3, 4, 5 terms. So I'm going to need, is it going to be 3 or is it going to be 4? So think about this. If it is 3, this square is going to give me 1 value. There's 2, there's 3, there's 4, there's 5. So that we need a 3 by 3. All right, so then I'm going to put my numerator over here. So it's going to be x to the 4th. And then this diagonal is going to give me 4x cubed. And then this diagonal is going to give me 3x squared. And these two are going to give me 4x. And this one is going to give me a 2. Okay, so there's my setup. And I start with my corners. X to the 4th here, this has to be x to the 4th because it's the only thing that is giving me that x to the 4th. And this has to be 2 because 2 gives me this 2. So then I can start filling in my top. 1 times what is 2? Well, it's 2. So this is 2. So once I find that, I can find these two. X squared times 2 is 2. Whoops. Let's stick with the colors in there. Is 2x squared. 0x times 2 is still 0x. And I'm going to write that. Okay. Alrighty, so then I come over to here. Well, I need a 4x and that's 0. So this has to be 4x because 4x plus 0x is 4x and 4x times 1 is 4x. So I need a 4x up here. So 0x times 4x is still 0x. And this is going to be 0x. That's easy. And then x squared times 4x is 4x cubed. And 4x cubed plus 0 is 4x cubed. So we're making progress here. All right, we have a 2x squared. We have a 0x. Oops, that's supposed to be squared. Right? 0x times 4x is 0x squared. And 0x times something is going to give me 0x to some power. I'll just leave that blank for now. But now working across here, 2x squared plus 0x squared is 2x squared. And I need 3x squared, so I need one more x squared. So 1 times x squared is, oops, well, let's just do this, x squared. And then let me change this color to purple and this one to purple. So they're all uniform. So we can see our answer. And our answer is in purple. It is x squared plus 4x plus 2. Okay, and there we have it. It's kind of neat. All right, page 3. This is page 3. Now it says to test your conjecture. Use the reverse tabular method to find the quotient. So again, we're going to do this one more time, actually 2 more times. Anyway, so here is my table. And down the side, I am going to write x squared. Don't forget your middle term. Don't skip them. It's 0x and 4. Okay, so we're going to have 3. And then this helps set up our table. We know at least how tall it is. All right, so here's our box. We have 1, 2, 3, 4, 5, 6 terms. So for starters, I know that it's 3 rows. Okay. Okay, close enough. So there's 3 rows. But if I have 1 square here, that's 1, 2, 3, 4, 5. I need 1, 2, 3, 4, 5, 6. I have a constant 1, 2, 3, 4, 5. Okay, so if I put, whoops, what happened there? If I put 4, is that going to be the right value? So this will give me 1, 2, 3, 4, 5, 6. So there it is. It's going to be 4. All right. So let me just make these a little bit more uniform. That looks pretty good right there. So there's our table. We write our numerator over here. This box is going to give us 3x to the 5th. So I'm just going to put 3x to the 5th right there off the bat. And this is going to give me a negative 2x to the 4th. And these 3 are going to give me 6x cubed. And these 3 are going to give me negative 4x squared. And these 2 are going to give me negative 24x. And this one is going to give me 16. So I'm going to put a 16 here. And let's change the color inside so we can decipher what these all are. Let's make them blue. Okay, so there's our starting point right there. The first term and the last term give us those corners, and that gets us started. 16 divided by 4 will give me 4. 3x to the 5th divided by x squared is 3x to the 4th. I'm sorry, 3x cubed, right? Subtract your exponents. 5 minus 2 is 3, 3x cubed, okay? And I don't want those green because that's my answer. Let's do the answer in purple. And let's do the answer in purple. Okay, and this should be green. Whoops, I see what happened there. Delete. Let me just make these the right color. This was 3x to the 5th, and I want this one blue, 3x to the 5th. Okay, and wait a second, that's purple. Okay, so here we go. So as I was saying, this first term is going to be this box by itself in the corner, and this last term is going to be this box by itself in the corner, and that sets us up for 2 of our values in our quotient. So I already know it's going to start out with 3x cubed. All right, so inside I want blue, so let's use blue. So now that I have this 4, I can do this column. X squared times 4 is 4x squared. 0x times 4 is 0x. Skipping over to this column, x squared times 3x cubed is going to be 3x to the 5th, which I already have. Okay, x squared times 3x cubed is 3x to the 5th. 0x times 3x cubed is going to be 0. x to the fourth. 4 times 3x cubed is 12x cubed. Okay? And then I look at my 2's here. Now I can fill this in because I know this, and the sum gives me this. So if I have nothing here, then this has to be negative 2x to the fourth. Because negative 2x to the fourth plus 0x to the fourth is negative 2x to the fourth. I can do the same with this here. 0x plus something equals negative 24x. Well, that's going to be negative 24x. So negative times a positive is negative. And 24 divided by 4 is 6. And then x. So now I have this. I can finish this column. X squared times negative 6x is going to be negative 6x cubed. That's supposed to be blue. Okay. 0x times negative 6x is going to be 0x squared. Now I have 2 of these diagonals out of 3 that gives me this, and 1 is 0. So 4x squared plus something gives me negative 4x squared. Well, that has to be negative 8x squared, because negative 8x squared plus 0x squared plus 4x squared is negative 4x squared. So now I have this value. 4 times what gives me negative 8? Well, it's going to be negative 2x squared. 0x times negative 2x squared is 0x cubed. Wrong color again, buddy. Okay, so there is our table. There is what our numerator. Here is our denominator with a spacer, and here is our quotient. So then I come over here, and it's 3x cubed minus 2x squared minus 6x plus 4. Whew. All right, that was pretty neat. Number 6, what is the quotient of these and what is the quotient of this? All righty. All right, so here we go. It is the same directions. Do we want to still use this, or do we want to go into something else? I will just keep doing this, I suppose. So I'm going to draw a table, and I do the right side first. And there's just going to be 2 terms. So I am going to draw my x and my minus 1 here. Okay, so there's my box there. And I have an x to the 5th minus 1. Uh-oh. I have a feeling this thing's got to be way out here. Okay, and I'll explain that in a minute. The reason I'm thinking there's going to be a lot of stuff going on here is because I have to write my spacers in. So x to the 5th, I'll do that in green. X to the 5th has to come from this first square. So let me draw that first square right here. All right, so this square is going to give me x to the 5th. Draw another one. These 2 are going to give me 0x to the 4th. These 2, okay? And I need to draw another one. These 2 are going to give me 0x cubed. I can't skip these. 5, 4, 3, 2, 1, 0. All right, that's what I'm doing here. This one and this one is going to give me a sum of 0x squared. This and this will give me a sum of 0x, and this will give me a sum of negative 1. So there we have it. We have 1, 2, 3, 4, 5. So the degree tells us how many we have in our row, or does it? The degree is 5. I have 5. Well, not necessarily, because the degree was 5 here and I only had 4 because of the number over here. So let's get back to that in a moment. All right, so remember, when we're doing this, you can put the first corner in because it's all by itself and gives us x to the fifth, and this will give us -1. Well, -1 times what gives me -1? Well, that is going to be 1. So 1 times x is x. That's 1x. And I want 0x, so this has to be a -x to get 0x here. And then if I have a -x here, -x times -1 will, or divided by -1 will give me a positive x. So -1 times x gives me -x. So this is x. So x times x is x squared. Adding this to get this is 0. So this has to be a -x squared. To get -x squared divided by -1, I get an x squared up here. So -1 times x squared is -x squared. X times x squared is x cubed. And I need a 0x cubed here, so this has to be a -x cubed. And it just keeps going like this. -x cubed divided by -1 is x cubed. And x times x cubed is x to the fourth. Okay. And x to the fourth minus x to the fourth will give me 0. All right. So these should all be blue, by the way. Let me change them. Okay, so those are all blue. Okay, so here is our numerator, here is our denominator, and I just need to finish up that top term here. X times x to the fourth will give me x to the fifth. So this quotient is going to equal x to the fourth plus x cubed plus x squared plus x plus 1. Okay, now we're going to do x to the 6 minus 1 divided by x minus 1. So I'm going to draw a table. We want x minus 1 down the side, which will split this into 2 rows. Okay, let me just fix this a little bit. Okay. I'll put x and -1 here for the denominator, x minus 1. And the numerator is going to be what goes around the bottom outside here. And I'm going to need several of these. So this diagonally, this was 1, 2, 3, 4, 5, 6. Now I need x to the 6th, x to the 5th, x to the 4th, x cubed, x squared, x, and -1. I need 7. Okay. So here's 1, 2, whoops, what's going on here? 3. So if I'm counting diagonals, 1, 2, 3, 4, 5. So 1, 2, 3, 4, 5, 6, and then this 7. Okay, so that should be enough. So then I'm going to write x to the 6th. So that would come from this diagonal, this square only, x to the 6th. So I'm going to put x to the 6th here. These two diagonally are going to give me the second term, 0x to the 5th. These two are going to give me 0x to the 4th. These two are going to give me 0x cubed. This one and this one will give me 0x squared. And this one and this one will give me 0x. And this one will give me my -1 down here, right here. So this is 1. Make this blue. Let me rewrite this because it's all the same color. X to the 6 goes here. and it also goes here. This square is always your first term outside here. This last one is always your last term outside here. So that's got to be a -1. So then I asked myself, so to get this -1, this had to be -1 here. And to get -1, I have to multiply by 1. So this will be a 1 up here. -1 times 1 is -1. So now if I take x times 1, I get this x right here. Well, I need 0x, so this is the opposite. X plus a negative x will give me 0x. So it's this diagonal giving me this sum and continuing throughout. All right, so now that I have this -x here, then I just work off of this -1. Well, -1 times -x is x. And actually, just a moment, these need to be blue. I'll just get rid of these now. This is blue. Okay, so let me fill in with blue. So -1 times x is -x. X times x is x squared. I have a 0x squared here, so diagonally this has to add up to nothing. So this has to be a -x squared here. -x squared times -1 will give me x squared. So this is x squared. And then x times x squared is x to the third. So this has to be -x to the third to get us 0x cubed here. And now I have this -x cubed times -1 will give me x to the fourth. I'm sorry, x to the third. -1 times x cubed is -x cubed. X times x cubed is x to the fourth. That's where I want the x to the fourth. And I didn't change it to blue. Okay, and then we're going to do our diagonal. So x to the fourth minus an x to the fourth right here will give me 0x to the fourth. And now I can take -x to the fourth times -1, and that will give me an x to the fourth for right here. And then when I multiply x times x to the fourth, I get x to the fifth. Let me change that color. I meant to make it blue. Okay. So since this is x to the fifth and I want 0x to the fifth from this sum of the diagonals, this has to be a -x to the fifth. And then x to the sixth is equal here. X times x to the sixth is, or x times x to the fifth up here will give me this x to the sixth. Okay, x times x to the fifth, x to the sixth. So I now finish, let me erase this and this. Whoops, not that. Anyway, so this is going to equal, this right here is right here, x to the fifth plus x to the fourth plus x cubed plus x squared plus x plus 1. Alrighty, so there is the quotient of these two fractions right there. Okay, page 4 brings us to the end of lesson 3. Go do your problem set.